Then create another guy, something that may be using a second constructor, like 3 divided by 1. And this will be a rat2. And then the idea is this, that we can say if rat1 equals rat2, then, you know, we can just test our somewhere here, I can just say using namespace std to make it, you know, visible. So I can say cout is true. New line. Okay. Otherwise it's false, something like that. Okay, something very simplistic. But of course, the key point is, how do we provide this? And so we start in our the header file, and we can basically say right. So we keep everything in good order. So the way we're going to do this, first, as you see, as a member function of our class. In order to be able to overload equal equal, we're going to name our function operator equal equal. You can immediately see that this is, you know, C++ actually uses operator, reserves operator to be a keyword of the language, because it's used to overload operators, right? So if we get into the business of overloading operators, this becomes our function name. This function with this strange name will be called as soon as someone tries this, to compare by equal equal. Okay. So in case if this is if we begin to overload equal equal as member function of our class, then we're actually assuming, I would think, that we're assuming that we have an object, right? So essentially, let me rewrite this just to make it perfectly clear. So instead of doing this, which most people will try to do, what's going to happen is that this will become exactly as saying rat dot operator equal equal this. So making a member function call. Basically, taking rat1, we already have this object, calling function name operator equal equal, and the parameter to this function is rat2. So therefore, let's maybe keep this in view, right over here. In that case, what this should be doing, what this function should be taking as a parameter is another rational. Perhaps we don't want to copy it, so therefore it should be taking a reference to another. I usually take, you know, in situations like there's one object and another object, but the type is the same. I have this habit of naming that other object, basically saying other, another, or other, just to kind of remind myself that this is another guy, but it's the same rational. So I have an instance. I am called on this instance, and this call receives another object as a parameter, and I pass it by reference so that no copy is manufactured. I have only two objects, and I want to analyze them in this function call. So therefore, most likely, I will say this function is constant and does not modify anything. I would also like to say that perhaps there is absolutely no intent inside this function to modify another guy. Because it's passed by reference, I could just go ahead and change it. But I would like to explicitly say that other is a reference to constant rational. Therefore, the promise is that this operator function will not change it. And I'm assuming that the operator equal thing, it can just return a Boolean result, true or false, right? So that's the idea. So this is the entire signature of this function. So hopefully, if I didn't take too many mistakes, then I can add a semicolon at the very end, right? So constant qualifier basically says, we have this function, but we would like to actually tell the compiler that this function is constant, which means that this function, the constant qualifier, which applies to this entire function, right? So this function declaration that we deal with suggests that this entire function is constant function, which promises not to modify any of the data inside of our object, which is this and this. We have two pieces of data. We promise not to modify it, and we shouldn't be anyway. All right. So then, taking this declaration, Control C, copy it, and go to our implementation file. Right. So edit here. Of course, get rid of semicolon. Add the body of the function, and what we can do is this. So if one fraction looks like this, d1 divided by numerator, denominator, and we want to test the equality between those two, we can say that this is n2 divided by d2. Just to kind of get a grasp of what's involved in comparing it. So in this case, we can sort of like rewrite this as, essentially we can say if n1 times d2 equals n2 times d1, then you get the answer. Right, so essentially, maybe this is the answer, right, that we should be looking for when we're comparing it. So we simply say return. Okay, return what? So take our numerator, which is our own numerator, multiply it by the denominator of the other guy, right? D2, and compare this result of this multiplication with, since I'm running out of space on a single line, I will just basically type everything on, vertically like this. So this time we will say other numerator multiplied by our denominator, something like that, right? So that should work, I think, right? So let's try to test this. Let's try to compile it. I know it seems to be unhappy about something. I don't know what it is. Let's just try to build this and see what error messages I get, if I get anything. So it says, just go straight to the output window. So it says here, equals modifier not allowed on non-member functions. Double equal modifiers. Oh, modifiers are not allowed on non-member. Oh, of course. Oof. All right. So as I copy and paste, I never told my compiler that this thing comes from the rational class, right? So this has to be specified that, hey, this operator is a member function of the rational class. So that's why I get this confusing message, because it was saying that doing this is not allowed on non-member functions. Specifying specifying const qualifier, doing this is allowed only on member functions of our classes, and that's the rule. So the syntax was immediately considered to be illegal in before I added, the scope resolution of my class to this operator, and so anyway, so this should work, right? So this should work. We should compile it now. Okay, and if we run it, so it says rat1 equals rat2 is false. So it did do the job. Basically, it returned, what it did was, of course, compared this value to this value and happily return the Boolean result of that, true or false, right? So this we know it works for integers. Now it works for rational. So you get the idea. So it's very routine. It's very boring business of writing all of overloading operators. But once done, it's acceptable. So let's save this.